Okay, well, thanks for the opportunity to present, and apologies I wasn't able to do it last month. Okay, just as a bit of background, I'm a technical director for ACOM in the Advanced Materials and Strategic Asset Management team, and my role is largely about durability of materials, predominantly on major infrastructure elements at the moment, with the goal to always incorporating as much sustainability into the concrete as we can. So we've put together a bit of an ambitious title for this presentation, which is How to Achieve Sustainability Targets for Concrete Materials on Major Infrastructure. So let's see how this goes. Okay. A typical design approach is for major infrastructure, you gain what's called generally a project requirement scope, which tells you what the basic requirements are for the project. You will have a bunch of structural assets that you're trying to build and some information around that, and usually some inbuilt sustainability targets. For concrete, these can often be quite poorly defined. It may be a minimum SEM content, a cement reduction target, sometimes with no basis as to what the target is being assessed against, sometimes it is. Or it may have a greenhouse gas emissions reduction target. So the process is typically the structural designers look and develop a design, and one of the outputs for the concrete is compressive strength, cast in situ, precast, and literally where it's going to be on the project. As a durability team, we would look at what the exposure classification is, embedding climate change into that so we know what's going to happen over the life of the structure, and then we'll literally assess how it's going to hold up and degrade over its life. Into that, we will start developing minimum durability requirements, to which we can fairly readily, generally, input the sustainability targets. Our next target is to fully develop the life cycle embodied carbon assessment. This is something we're just on our journey to developing. The process then is it goes through a design verification compliance to make sure it meets the project targets. If it doesn't, well, it gets looped back around. We then issue it to construction and procurement teams for the next phase of a project. However, it doesn't end there. Within this approach itself, there are a number of challenges to success in getting a sustainable project. We find a lot of the teams have different drivers, and sometimes these might conflict. So the sustainability team is purely focusing on their targets, sometimes not how we can get there. The structural team, as expected, you would want them to concern themselves mainly with the performance requirements of the structure, because if it doesn't meet the performance requirements, it really doesn't matter how sustainable it is. It's got to meet those targets first. In the durability team, we're most interested in ensuring it doesn't degrade to unacceptable levels during its design life. But the construction and procurement teams are often most focused on program and costs, and sometimes we get a bit of a conflict between these. That's not where the challenge is finished, though. We also find with the current Australian standards and various state road authority concrete specifications, there's a number of limitations that really can prevent us, if we stick to them, from getting to our SEM targets, for instance. DTP is or was Vic Roads, and their specification really limits what you can do. So you always have to try and push beyond these limits. AS 5100 also has limits, but they're a lot more realistic. So, for instance, you can put up, in certain environments, up to 70% slag in a mix, whereas the DTP specification limits you to 40%. Not ideal. The next limitation with these specifications is it resolves around the high minimum cement contents that are mandated in these. So this is the DTP specification, and you can see it's got quite high minimums, no maximums. This is something that we find a lot of issue with, particularly with precast elements. But when we go and look at some of the Australian standards for the same 32 MPa concrete, they nominate as low as 285, which seems to be a little more realistic. The actual strength you get, though, is going to be very dependent on the cement, the SEMs, and the size and quality of your aggregate. So it's not just your cementitious content that's going to guide you as to whether you will get the right cement strength. Hence, you do trials. But it's these high minimums that are a concern. But what other challenges are there? Often you find where there's a lack of knowledge, there's a real risk aversion. They don't want something that hasn't got proven performance. Construction teams, if they're unsure about how it's going to be in the construction, is it going to be sufficiently workable? Is it going to have the early strength required to strip the formwork? They will push back. So there's also a lack of understanding on how to specify concrete that is in excess of the various standards and various road authority specifications. For instance, if you nominate a DTP or Vic Roads VR 440 concrete, that will seriously limit the maximum allowable SEMs. So that's not adequate for the projects we're currently doing. So it's actually far better to nominate, for instance, an S40 concrete, which is approved by DTP, and nominate the minimum SEMs you're after. And we're very aware that they are approving SEM blends in excess of their own specification. And this wording in your documentation will prompt people not just to specify and accept what's in the DTP specification. There is also quite a poor understanding of how to develop and register, particularly in Victoria, if you're on a Vic Roads project, the new sustainable concrete mixes. And this is a real challenge to procurement teams, as well as sometimes the design teams. Construction program and costs can be a real challenge to overcome as well. If during the bid phase they've assumed certain production rates of precast units, and certain strength gain out of the concrete, then if we're using high SCMs and they're not aware of some of the limitations or how to modify them using appropriate additives, then they're not going to get what they expect and they can't meet either the program or the cost. Because if you change the production rate of a precast plant, your costs are going to go up. So that's just something to keep in mind. Okay, so how do we try and turn these challenges into success? The most important thing is to collaborate, form an alliance, and educate. So promote the concept of one team and remove silos. If you've got silos, that means you're not effectively communicating your needs successfully to the other teams, and you won't achieve the project goals with respect to sustainability. So you need to clearly define and discuss the challenges of each team and develop a project-wide approach. If necessary, develop guidance documents. Timing and testing requirements for new concrete mixes is a very important one. In fact, DTP themselves issued a document in September, so just recently, which goes through and tells you how to develop a new mix, how to register it, and what sort of timing you need to think about. I actually think their timing is still a bit slim. They recommend up to 3 months before you want to use it. I suspect you are still going to need more time to develop it adequately. You can also, and I think this is a good idea, develop project-specific concrete specifications. Within this, you can optimize the SCM content, any additives, minimize cement content, but you must also clearly define where your specification differs from the Australian or state-based concrete specs. Go into this in some detail and clearly state which parts you still apply, you are still going to apply to your concrete assets, because it's important to get it as close as possible to these specifications for the purpose of the approval process. If you don't follow the same process, how are they going to make sure that they're comparing apples with apples when it comes to particularly the performance requirements that are embedded into these documents? But don't just put it in a specification. If it is not on a drawing, a lot of construction teams will not see your notes. So it must go on your drawings as well, what the differences are. Don't just say, yes, it's a 40 MPa concrete. Say it's a 40 MPa concrete that complies or has been approved by DTP, but it does have specific SCM contents. Make it clear, make it easy for everyone to achieve what we need to. Another thing we're finding is to being a very good idea is on a lot of these major structures, there's often temporary structures that are needed before the permanent one's built. This gives us the perfect opportunity to do trials. We can do constructability trials to get the construction team familiar with the use of these new mixes. We can do performance trials and monitor them. And we can also then create lessons learned. And if we can, share it outside of the project team, share it with a much wider audience, in an audience like this, in the Concrete Association, the Corrosion Association, wherever you can, share the learnings, because then other projects have got a much greater chance of success as well. And that's it in a nutshell. A little bit quick. It is a basic framework. We are working on this pretty much every week to try and develop stronger and stronger ties between teams so we can have successful projects. Thank you.
Thank you very much for that, Sarah. So